GDS Lab version 2024 video tutorial 5.3.7, running an advanced 1D consolidation test. This module offers independent control over relevant tests, similar to what we've seen with advanced loading for triaxial and shear tests. Today, we'll demonstrate how to set up and configure a consolidometer test. So we'll start with the consolidometer test type. There's only one standard available for this test. A consolidometer test involves applying an axial load to a sample confined within a steel ring, preventing lateral movement and keeping the diameter constant throughout the test. So let's move forward and set up a new test. The sample used in the consolidometer test is similar to a hockey puck. So in my example, I'm going to set the height to 20 millimeters and the diameter to 70 millimeters. So next we're going to the test module list for consolidometer, and we have advanced loading, logging, monotonic loading, permeability, and user-defined modules. For this video, we're going to be focusing on the advanced loading module. So we're going to go ahead and select that. And then the vertical control parameters in consolidometer tests are axial load, axial displacement, axial stress, effective axial stress, and axial force. So axial load controls the load applied vertically, axial displacement controls the vertical movement, axial stress controls the stress applied vertically, effective axial stress subtracts the internal pressure from the applied axial stress, and axial force controls the overall force applied to the sample. So for the mode options that we have for each of them, we have constant, ramp, slow cyclic, or halt. Then we have optional back pressure controls. So this controls the pressure within the specimen, either by pressure, volume, or flow rate. We can set the mode to constant, ramp, or cyclic, similar to other advanced loading modules. An example would be we could enable back pressure control and set it to maintain a constant pressure of 100 kPa. Then we also have temperature control, if available. For systems with environmental temperature control, we can control the cell temperature. There's only one option available for temperature control. You can enable the temperature control and set it to the desired temperature, but we're not going to do that in this example. Then we also have the excess pore pressure control, where we have the option to define a maximum excess pore pressure force, and if the pore water pressure exceeds this value, the system will pause to allow dissipation before resuming. This prevents excessive pressure build-up within the sample during loading. We also have the usual test termination conditions that are very similar to most tests that we run. So we have set the back pressure at constant to 100 kPa, and we've asked the axial load to ramp from 0 to 2 kilonewtons over 1 minute. So we're going to go ahead and try to start the test. We need to make sure that the graphs display a back pressure, axial load, and axial displacement, and then we can start the test. As the test goes on, you can see that it's behaving as we would expect. So anyway, yeah, that is the end of this video. This has been running an advanced 1D consolidation test. Thank you.